Okay, so in this section, we're going to talk about what are called power functions. So a power function is when you have a function in the form f of x equals k, that's supposed to be an x to the p. So you're allowed to have what's called a coefficient. Hopefully we've talked about those before. Or a real number in front of the variable. And you're allowed to have an exponent. And then both k and p are real numbers. Okay, so in example 5.10, it says, which of the following functions are power functions? Okay, well, let's look at the obvious ones. This one's obviously a power function because it's 1x squared. This one's obviously a power function because it's 1x to the third. Okay, now let's look at the constant function. F of x equals 1. They chose 1 as the constant. You could write that as 1 times x to the 0, and that fits the form. So, yeah, that can be a power function. The second one, the identity function, well, that's x to the first, right? Just x. So that's a power function. Coefficient is 1 there, by the way. Okay, let's go to the reciprocal function. You could write f of x equals 1 over x as x to the negative 1. So that fits the form. And then you can imagine on this one, the reciprocal squared function, 1 over x squared is equal to x to the negative 2. So that's a power function. And the last one, f of x equals x to the 1/2. You can write a square root, right? Like as x to the 1/2. So you can write that as an exponent that's a fraction. And that fits the rule. We just have to have a coefficient. All of these are having coefficients of 1. And then an exponent. And so the last one, you can imagine, f of x equals x to the 1/3. And so that's a power function. So they all can be written in the form k, I forgot, x to the p. Okay? They can all be written in that form. Therefore, they can all be identified as power functions.